Good day, friends. Welcome to Royal Learning Channel. My name is Oluwatoyin. Today we are going to dig through another topic in organic chemistry called alkanoic. Alkanoic. Alkanoic acids are also known as carboxylic acid. They are also called carboxylic acid. Then alkanoic has a general formula of RCOOH, whereby the COOH is the functional group of alkanoic. The COOH is the functional group of alkanoic. Then the general formula of alkanoic acid can also be written as CnH2n plus 1 COOH. CnH2n plus 1 COOH, whereby CnH2n plus 1 is the molecular formula of what? Of our key group from this general formula. So we derive the molecular formula for members of alkanoic from this general formula. We derive the molecular formula for members of alkanoic from this general formula. The members of alkanoid are obtained by replacing the name ending from corresponding alkane with oic. Their names are obtained by replacing the name ending from a corresponding alkane with what? With oic. Then the first member will be what? Metanoic, derived from methane. It is derived from methane. So the name ending E is replaced with what? With oic. So therefore you call this what? Metanoic. So the first member is metanoic. Then the second member will be called what? Ethanoic. Ethanoic acid, which is also known as acetic acid. Then the third member is propanoic. Then the fourth member is butanoic acid. Then the fifth member is pentanoic acid. Then followed by hexanoic acid, ethanoic, octanoic, nonanoic, and what? And decanoic. So these are the first 10 members of what? Of alkanoic acid. Then you derive their molecular formula from this general formula. You can derive the molecular formula for each member from this what? From this general formula. For metanoic, the number of mole, which is N, equal to 0. For ethanoic, the number of mole is 1. Then for propanoic, N is what? Is 2. Then this one will be 3. And so on. So to derive the molecular formula for metanoic, you substitute this 0 into this general formula. C times 0 will give me 0. Then 2 times 0 is 0 plus 1. That is 1. HCOOH. So that is the what? The molecular formula for the first member. Then for the second member, my N will be 1. C times 1 will give me C. 2 times 1, 2 plus 1, that is H3. Then followed by your functional group. So COOH. That is the molecular formula for the second member. So you can derive the molecular formula for other members from this general formula. Then we have higher members of homologous series. The higher members of homologous series are obtained naturally from fat and oil. The higher members of homologous series are obtained naturally from fat and oil. So they are called fatty acid. Then the fatty acid is divided into two categories. The fatty acid is divided into two categories. Then we have saturated fatty acid. The saturated fatty acid. Number 1 is saturated fatty acid. Then the saturated fatty acid do not have double bond in their carbon chain. They don't have double bond in their carbon chain. So they are higher what? They are higher members of what? Of alkanoic acid with long chain of what? With long chain of hydrocarbon. They have long chain of hydrocarbon. Example of saturated fatty acid, like I said that the saturated fatty acid, they do not have double bond in their carbon chain. They do not have double bond in their carbon chain. So examples of saturated fatty acid are e.g. Number one is decanoic acid. Decanoic acid. Decanoic acid is also known as capric acid. Capric. It is also known as capric acid. Capric acid. So the decanoic acid is obtained from goat fat. So goat fat is called decanoic acid. Goat fat is called decanoic acid. Then what is the formula, the molecular formula for decanoic acid? Then decanoic, that will be the what? The 10 members of what? The 10th member of what? Of alkanoic. The 10th member of alkanoic. Then the 10th member of alkanoic will what? It will have 10 carbon atoms in its molecule. So that will be CH3. Then when the first carbon atom takes C, then the carbon atom from your functional group will also take another what? Another one carbon atom, COOH. Out of 10 carbon atoms, because deca is what? Deca is 10. So out of 10 carbon atom minus 2 carbon atom is will remain what? 8 what? 8 carbon. So CH2 into bracket what? Into bracket 8. So this is the molecular formula for what? For the 10th member, which is called what? Decanoic acid. If you apply this general formula, you are still going to obtain the same thing. So let's use this general formula. Maybe we are still going to obtain the same thing. Then if my n is what? Is 9 from this general formula, don't forget that of pentanoic will be 4, hexanoic 5, 6, 7, 8, 9. So the number of mole, which is n, will be 9. So substitute 9 into this general formula. That will be C times 9 will give me C9. 2 times 9, that is 18. 18 plus 1, that will be what? 19, Abi. Then COOH. So how many carbon atoms altogether? 9 plus 1, 10. So likewise this one, 1 here, 8 times 1, that's 8. 8 plus 1 plus 1 will give us 10. Then let's count the number of hydrogen atoms that we have from this formula. 8 times 2 is 16. Then 16 times 3. 16 times 3 will give us what? 8 times 2 is 16. 16 plus 3. 16 plus 3 will give us what? 19. Then 19 plus 1 will give us 20. So 19 plus 1 here to give us what? It gives us 20. So they have the same general formula. So you can derive the general formula for members of alkanoic from this general. It shows that you can derive the general formula for members of alkanoic from this general formula. So this is formula for what? For decanoic. Decanoic is known as what? Capric acid. And it is obtained from what? From goat fat. From goat fat. Another one is hexadecanoic acid. Hexadecanoic acid. Saturated fatty acid. So A is decanoic. Then another one is hexadecanoic acid. Then the hexadecanoic acid is also known as palmitic acid. Palmitic acid. Then palmitic acid is derived from palm oil. Palmitic acid is derived from palm oil. So from what? From palm oil, obtained from palm oil. Obtained from palm oil. Then what will be the what? The molecular formula for hexadecanoic acid. Hexa means 6. Then deca means 10. So 6 plus 10, that is what? 16. So it contains what? 16 carbon atoms in its molecule. It contains 16 carbon atoms in its molecule. So let's write the molecular formula for hexadecanoic acid. First write the first CH3. Then write your general form, the functional group, which is COOH. Then the carbon atom from here, from this CH3, 1 plus the carbon atom here, that is 2. Then minus it from 16 carbon atom. So 16 minus 2 will give us 14. So CH2 into bracket what? Into bracket 14. So this is the general formula for hexadecanoic acid, which is known as what? Palmitic acid. Palmitic acid. Then another example is octadecanoic acid. Octadecanoic acid. Octadecanoic acid. Octadecanoic acid, which is known as what? Stearic acid. Stearic acid. Then the stearic acid is obtained from animal fats. The stearic acid is obtained from animal fat. Animal fats like beef. Obtained from animal fats like beef. Then let's write formula for octadecanoic. Octa means 8. Then deca means 10. So 8 plus 10 will give us what? 18. It shows that octadecanoic acid contains what? 18 carbon atoms in its molecule. So let's write formula for that octadecanoic acid. Don't forget that it contains what? 18 carbon atoms. So the CH3 first, then write your functional group, that's COOH. So 1 carbon atom plus 1 carbon atom here, that is 2. So take away 2 from 18, we give us 16. Then the CH2 will now carry what? It will carry 16. This is the molecular formula for octadecanoic acid. So these are the common examples of saturated fatty acid. Saturated fatty acid. Then another type of fatty acid is called unsaturated. The unsaturated fatty acid. So examples of unsaturated fatty acid are: number 1 is 6-octadecanoic. 6-octadecanoic. Then let's write formula for 6-octadecanoic. So it shows that it contains what? 1 double bond in its molecule. It contains 1 double bond in its molecule. So then the double bond is on the 9th carbon atom. That's why they said 9-enoic. This En is from alkene. That is double bond. So the double bond is on the 9th carbon atom. That is the meaning. So let's write. Then octadeca is still 18. So the structure contains what? 18 carbon atoms in its molecule. So the only differences between octadecanoic and octadecanoic is the presence of double bond. So let's write the molecular formula for octadecanoic. So the first CH3. Then after that, don't forget that it's the 9th carbon atom that will carry what? Double bond. The 9th carbon atom will carry double bond. So 1. So we need how many carbon atoms? We need 7 more carbon atoms. 8 carbon atoms. CH3, CH2, then 7. So 1 plus 7 carbon atom, that is 8. So 8 plus what? Plus another one, then we have CH, then double bond. So the 9th carbon atom now, 1 plus 7, that is 8. 8 plus 1, that is 9. So the 9th carbon atom carries what? It carries double bond in its structure. So followed by another carbon atom now, so making 10. So out of 18, we are left with what? With Out of 18, so we are left with 8 carbon atoms. So your functional group will carry 1 out of that 8. Then CH2 will now carry what? The remaining 7. So by the time you count the number of what? Of carbon atoms that you have here, it will be equivalent to what? The 18, which is octadeca. So 1 here plus 7, that is 8, 9, 10. 10 plus 7, 10 plus 7, that is 17. 17 plus 1 is equal to what? Equal to 19. So this is the formula for octadecanoic. Octadecanoic. Then octadecanoic is also known as oleic acid. Oleic acid is also known as oleic acid. Then oleic acid is obtained from olive oil. The oleic acid is obtained from olive oil. So another example of unsaturated fatty acid is 6-octadeca-9,12-enoic. 6-octadeca-9,12-enoic. That's another example. So number 2 is 6-octadeca-9,12-dienoic. 6-octadeca-9,12-dienoic. So it shows that the double bond is what? Double bond is on the 9th carbon atom and is also on the what? The 12th carbon atom. Double bond is on the 9th carbon atom and is on the what? Is on the 12th carbon atom. Then the octadeca is still what? 18 carbon atoms. So the octadeca-9,12-dienoic contains what? 18 carbon atoms in its molecule. Then the octadeca-9,12-enoic is obtained from vegetable oil. It is obtained from vegetable oil and it is called linoleic acid. Linoleic. It is called linoleic acid. That's another name for 6-octadeca-9-enoic. 6-octadeca-9,12-enoic. So it is called what? Linoleic acid. That's another name for 6-octa-9,12-dienoic. Then what is the general formula for, or the molecular formula for octadeca-9,12-enoic? So don't forget that it contains what? 18 carbon atoms. Then the double bond is on the 9th carbon atom and is on the 12th carbon atom. So our target now will be the 9th carbon atom, attachment of double bond to the 9th carbon atom and to the what? The 12th carbon atom. So let's write the molecular formula for this octadeca-9,12-enoic. So the first carbon atom with CH3. So we are going to the what? The 9th carbon atom. So followed by CH2 into bracket 7, then CH double bond. So 1 plus 7, that is 8. 8 plus 1, that is 9. So the first double bond is on the 9th carbon atom, then followed by CH. This is 10. Then we have another CH2. That is 11. So followed by what? 12. the 12th carbon, on the 12th carbon atom, there will be attachment of another double bond. There will be attachment of another double bond on the 12th carbon atom. So if you count from this side now, 1 plus 7, that is 8, 9. So the first in double bond is on the 9th carbon atom. So 9, 10, 11. Then on the 12th carbon atom, there's another double bond. Then CH, another CH. So how many carbon atom have we used? Out of what? 18. Don't forget that we are going to 18. Octadeca is 18. 1, 8 plus 7, that's 8, 9, 10, 11, 12, 13. 18 minus 13, that is 5. Then your functional group will carry 1. So that is 14. Now 18 minus 14 will give us 4. That will be CH2 into bracket 4. So this is the molecular formula for octadeca 912 what? Dianoic. Octadeca 912 dianoic. So those are the general what? The general examples of unsaturated fatty acid. Unsaturated fatty acid. So we also have another natural source of what? Of alkanoic acid or the carboxylic acid. So other natural sources of carboxylic acid are number 1, that is the first member. The first member, which is called what? Metanoic acid. Metanoic acid. Metanoic acid is obtained from ants and bee sting. When ants and bees sting you, the poison passed to your body is called what? Metanoic acid. It's called metanoic acid from ants and bee sting. From ants and bee sting. Then another one is ethanoic acid. That is the second member. Ethanoic acid. Ethanoic acid is obtained from vinegar. Ethanoic acid is obtained from vinegar. From vinegar. Then another one is butanoic acid. Butanoic acid obtained from butter. Butanoic acid is obtained from butter. Then another one is lactic acid. Lactic acid. From the word, the lactic acid is obtained from the word lactation. And what is lactation? Production of milk. So lactic acid is what? Is called sour milk. Is sour milk. Then we also have citric acid. Citric acid. Then the citric acid is from citrus fruits. From citrus fruits. Like citrus fruit, like lemon juice. Then we also have tartaric acid. Tartaric acid. Tartaric acid from grape juice. From grape juice or sour soup. So tartaric acid is obtained from grape juice or sour soup. So those are the natural source of carboxylic acid. The natural source of carboxylic acid. So let's talk about physical properties of alkanoic. What are the physical properties of alkanoic? What are the physical properties of alkanoic? So number one is the first to the third member. The first member to the third member are colorless liquid with sharp odor. They are colorless liquid with sharp odor, like odor of vinegar. Then the fourth to the eighth member, the fourth member to number eight members, they are colorless liquid with unpleasant odor. They are colorless liquid with unpleasant odor, while others members are colorless and odorless solid. They are colorless and odorless solid. Then number two, their boiling point increases as the molecular mass increases. Their boiling point increases as the molecular mass increases. Then the boiling point increases. Another one, the boiling point increases as the what? As the number of branches increases in case of what? Of isomeric members, isomeric homologous series of what? Of alkanoic. The boiling point decreases as the number of what? Of branches increases. Then another one, the alkanoic acid, the alkanoic member dissolve in alkanol. Then they can also dissolve in alkoxyalkane, and they can dissolve in what? In propane. They can dissolve in propane. They dissolve in propanone, the propanone. I mean, they dissolve in propanone, in alkoxyalkane, and in alkanol. Then the alkanol members, they have higher boiling points than alkanol. They possess higher boiling points than what? Than alkanol. So those are the physical properties of what? Of alkanoic acid. So in my next video, I'm going to explain method of preparation of alkanoic acid. I will explain method of preparation of alkanoic acid. Remember to subscribe to Royal Learning Channel and awake the champion of chemistry in you. See you in my next video. Bye.